is not learning of facts. It's making mind to think. Welcome to Old School Electrical, where we simulate minds to think. In my last lecture, we have discussed about electric potential, voltage and current. And in today's lecture, we are going to discuss about the fundamentals of electric field, simple cell and EMF. We are not going deep in electric field. For understanding the simple cell, we need the fundamentals. So I am touching on electric field, then moving on to simple cell. Finally, I am going to define EMF. So we will start with electric field. First, you should know one concept. When charges are in motion, it will produce magnetic field. So, charges in motion produces magnetic field. And charges at rest, that means stationary charges, produces electric field. So when charges are in motion, it produces magnetic field, and stationary charge produces electric field. So when current flows through a conductor, the current carrying conductor produces magnetic field surrounding that, because current is flow of charges. So when charges are in motion, when current flows through a conductor, it produces magnetic field surrounding that. On the other case, if charges are at rest, surrounding the charge, there will be electric field. Assume we have two plates, two metal plates. This metal plate is positively charged and this metal plate is negatively charged. And you know another concept. Opposite charges will attract and like charges will repel. So if you bring two positive charges together, it will repel. If I bring one negative charge near to the positive charge, it will attract. The positive charge will exert a force such a way to attract the negative charge. So there will be force of attraction between opposite charges and force of repulsion between like charges. Now this metal plate is positively charged and this metal plate is having negative charges. So these positive charges will exert and force over these negative charges. So these positive charges will exert a force over the negative charges. These forces will act in the form of parallel lines, and those are called electric lines of force. So the positive charges will attract the negative charges by a force, and the forces will act in the form of lines which are called electric lines of force. Clear? And all these electric lines of force together is called as electric flux. All these electric lines of force together is called as electric flux. So the space surrounding the charge body where electric flux exists is called electric field. Clear? So what is electric field? It is the space surrounding charge body where magnetic flux exists, where electric flux exists. Is the electric field. So electric field is nothing but the space surrounding the charge body where electric flux exists. Next, what is the direction of the electric field? That is very important. What is the direction of the electric field? The direction of the electric field is from positive charge towards the negative charge. So, direction of electric field is from positive to negative charge. It's directed from positive to negative, as I have marked. Okay. This fundamental is required for understanding the simple voltaic cell. Now, let's move on to an simple cell. I am going to explain how voltage is produced in a simple cell. So, in a simple cell, there are two metal plates. One metal plate made of copper and the other metal plate made of zinc. And these two metal plates, copper plate and zinc plate, these two are called electrodes. Clear? A simple cell comprises of two metal plates made of different material. One metal plate is made of copper, another metal plate is made of zinc. And these two metal plates are called electrodes. So, there is one copper electrode and one zinc electrode. And these two electrodes are dipped in a acidic chemical medium. And here we use dilute sulfuric acid. So, the chemical medium used is dilute sulfuric acid, H2SO4. This dilute sulfuric acid is the electrolyte. This is called as electrolyte. So, an simple cell comprises of copper electrode, zinc electrode dipped inside dilute sulfuric acid, and the dilute sulfuric acid act as an electrolyte. Now, chemical reaction take place between the electrodes and electrolyte. Chemical reaction take place between the electrodes and electrolyte. So, what happens is chemical reaction. And as a result of the chemical reaction, chemical energy is released. And it has its own associated chemical force. So, due to chemical reaction between electrodes and electrolyte, chemical energy is released, which has its corresponding chemical force. This chemical force charge the copper electrode to positive potential and charge the zinc electrode to negative potential. So, the copper electrode becomes the positive electrode, the copper becomes the positive electrode, and the zinc becomes the negative electrode. So, we have already discussed in the last class, for charging an body, we have to do work. So, for removing electrons or for removing ions from a neutral body, we have to do work. We have to apply energy. In this case, chemical energy is used. Chemical energy is doing work. Chemical reaction is doing work in removing electrons or removing ions. So, what work is done in removing electrons or ions from a neutral body to charge it? And the work done in charging the body will be stored inside the charged body as potential energy. That stored potential energy is called electric potential. So, this is charged to positive. Copper is charged to positive. So, The copper electrode now has an potential, electric potential. Zinc is another different metal. It is charged to negative. So for charging it to negative, we are removing ions from the zinc. For that we have done work. So that work done is stored inside the zinc electrode as stored energy. So that stored energy is called as electric potential. So zinc will have different electric potential. And the difference in potential between these two electrodes is called as potential difference, PD. The difference in electric potential between these two electrodes is the potential difference. The potential difference is also called as voltage. Clear? So what is the unit for electric potential? Work done in charging a body to 1 coulomb is the unit for electric potential, that is volts. Work done in charging a body to 1 coulomb is taken as the unit for electric potential. So electric potential is work done by charge. So joules per coulomb, also called as volts. So potential difference in electric potential, so it will also have the unit volts. Potential difference is also called as voltage. So what happens in the symbol cell? Symbol cell is a galvanic cell. That means chemical energy is converted to electrical energy. So voltage, in this way, voltage is produced in a symbol cell. So shall I repeat? Galvanic cell or the symbol cell has 2 electrodes, one copper electrode and one zinc electrode dipped inside dilute sulfuric acid, which act as an electrolyte. Chemical reaction takes place between the electrodes and electrolyte and releases chemical energy, and that chemical energy has corresponding chemical force. Because of that, the copper electrode is positively charged and the zinc electrode is negatively charged. So the work done in charging the electrodes is stored inside the electrode as stored potential energy. So it has the stored potential energy is the electric potential. So both electrodes has electric potential, and the difference in electric potential between these two electrodes is the potential difference, and the potential difference is otherwise called volt. So if you connect an electric bulb in between these two electrodes, there will be flow of electrons from zinc towards copper. Here there are more electrons. The electrons will flow from this positive plate will attract electrons. So electrons will flow from zinc plate to copper plate. This directed flow of electrons from zinc to copper is called electric current. When electric current flows through this bulb, through this lamp, part of the energy is converted to light energy. So we are getting light, or the lamp glows. This is what happens in a symbol cell. Now we are going to discuss in detail about the symbol cell. We got an overall picture, and now we are going to deep how the charging take place and how EMF is produced. We shall see all those. Okay. So out of the two metals, copper and zinc, zinc is an active metal. So we will start chemical reaction from the zinc electrode. So in a symbol cell, we have an acidic medium. How will you call this? Electrolyte. What is the electrolyte used here? Dilute sulfuric acid, H2SO4. I am starting with zinc. So I have dipped the zinc electrode. So what happens? Chemical reaction take place between the electrode and the electrolyte. The zinc is an electrode. Chemical reaction take place between the electrode and the electrolyte, and that releases chemical energy. So corresponding to that energy, there is a force. So because of that chemical force, the dilute sulfuric acid is split into dilute sulfuric acid near to the zinc. Sulfuric acid in this region is split into H2SO4 is split into hydrogen ion and sulfate ion. What does this 2 minus indicate? 2 minus as superscript, sulfate ion. It has 2 excess electrons. This hydrogen ion 2 plus, that means it has shortage of 2 electrons. Here there is excess of 2 electrons, here there is shortage of 2 electrons. So 2 plus, 2 minus, that's the meaning. So chemical force splits the dilute sulfuric acid into hydrogen ion and sulfate ion. The next action of chemical force is in the zinc electrode. Do you know the atomic number of zinc? Atomic number of zinc is 30. So how much number of protons are there? 30 protons. How much number of electrons are there? 30 electrons. And in last class we have discussed about electronic configuration. What is the maximum number of electrons that can be accommodated in an orbit? It is equal to 2n square is the maximum number of electrons that can be accommodated in an orbit. So first orbit means n equal to 1. So 2 into 1 into 1. So first orbit accommodates 2 electrons. Second orbit accommodates 2 into 2 into 2, 8 electrons. Third orbit accommodates 2 into 3 into 3, so 18 electrons. So how much it comes? 28. And the fourth orbit will have remaining 2 electrons. Last orbit of zinc has 2 electrons. In the previous lecture we have discussed about valence electron. What is valence electron? The electrons in the outermost orbit is called valence electron. What is the speciality of that valence electrons? The valence electrons will be loosely bound to the nucleus, because the last orbit is far away from the nucleus. The nucleus has positive charges, so it exerts force over the negatively charged electrons. Since the electrons in the last orbit are far away from the nucleus, the electrostatic force of attraction is less. So the binding force is less, or the binding energy is less. So this valence electron can easily come out of the atom. So electrons which are coming out of the atom, the valence electron which are coming out of the atom are called as free electrons. So in zinc we have 2 electrons in their last orbit, those are valence electron, and they are loosely bound to the nucleus. So these 2 valence electron will come out of the orbit. So if you take one zinc atom here, its 2 electrons will come out as free electrons. Now the chemical force pulls this zinc ion. When the 2 electrons goes out, this atom will become ion. There is shortage of 2 electrons. Zinc atom has a shortage of 2 electrons because it already loses 2 electrons. 2 valence electrons goes out. So it has a shortage of 2 electrons. It becomes a positive ion. That positive ion is taken out to the electrolyte by the chemical force. So the zinc atom leaves 2 electrons within the zinc electrode and it comes out as zinc ion. There is shortage of Zn2 plus. There is shortage of 2 electrons. Both the valence electron went out as free electron and that is not collected. So the zinc atom leaves 2 electrons within the electrode itself and it comes out as zinc ion to the electrolyte. In the electrolyte already we have sulfate ion which has excess 2 electron. Here there is shortage of 2 electrons. So these 2 combines. So next reaction which is taking place is the zinc ion which is coming out of the zinc electrode because of chemical force combines with the sulfate ion. Zinc has shortage of 2 electrons, sulfate has excess 2 electron, they combine together to form zinc sulfate. Clear? So what is left behind? This hydrogen. Hydrogen ions are left behind in this side. So here we have only hydrogen ions. And instead of this we will be having Zn SO4. we have zinc sulfate and just hydrogen ions. And next we will see the reaction at the other electrode. The other electrode is copper. What is the atomic number of copper? Atomic number of copper is 29. So similarly, if you distribute the electrons, first orbit will have 2, second orbit will have 8, third orbit will have 18, so 28, and fourth orbit will have 1 electron. This 1 electron is the valence electron, which is loosely bound to the nucleus. It will be available as free electron in the copper. So what happens next is the chemical force transfers this hydrogen ion from zinc electrode side to copper electrode side. So the hydrogen ion is transferred from zinc electrode side to copper electrode side through the electrolytic medium. So transfer of ion take place. The transfer of ion is from zinc electrode side to copper electrode side, and it is done because of the chemical force. The chemical force is moving the hydrogen ions. So once the hydrogen ion reaches here, at the surface of the copper electrode, chemical reaction take place. One reaction take place. The reaction take place at the surface is this hydrogen ion has shortage of 2 electrons. So it takes 2 electrons. It takes 2 electrons from the copper atom and it becomes hydrogen gas. So hydrogen gas is released at the copper electrode, and these 2 electrons comes from copper. So from copper, the hydrogen ion takes 2 electrons and becomes hydrogen gas. So this is the reaction which takes place in copper electrode. Are you clear? So when this reaction continues, what happens? The zinc will have more number of electrons, because when you take one zinc ion here, it leaves 2 electrons within the electrode itself. So each zinc ion which is coming out is contributing 2 electrons within the 2 extra electrons within the electrode. So zinc becomes negatively charged, and this copper gives 2 electron to hydrogen ion and it becomes positively charged. So once it is charged, it will have electric potential, and the difference in potential between these 2 charged particles is the potential difference. So we will be having voltage between the terminals now. As the charging progresses, the potential difference also increases, the voltage also increases. Now we have studied electric field. What is electric field? Surrounding a charged body, there will be an electric field. What will be the direction of electric field? Direction of electric field will be from positive plate to negative plate. So see, the copper plate is positively charged, the zinc plate is now negatively charged. So there will be an electric field pointing from positive plate to negative plate. So there is an electric force acting from positive plate to negative plate. So inside the cell, there are 2 forces. What are those? One is the electric force produced by this electric field. It is directed from positive to negative. Another one is chemical force. That chemical force drives zinc ion from zinc electrode, combines it with sulfate ion to form zinc sulfate, and it pushes the hydrogen ion to copper electrode. So chemical force does this ion transfer within the electrolyte. Ion transfer of ions within the electrolyte is taken by chemical force. So 2 forces are acting. So these 2 forces acts in opposite direction. So once electric field is established, once the electric force comes into action, the chemical force has to do work against that electric force. Overcoming that electric force, it has to proceed with ion transfer. So the charging rate decreases. Once the electric field is set up, charging rate decreases. Okay. And as the charging here, as the charges increases, here more positive and here more negative, as the amount of charge increases in zinc and copper, the electric field will also get strengthened. Electric force will also increase. Okay. At one point of time, the chemical force becomes equal to electric force, or the electric force becomes equal to chemical force. Both are opposing in nature. So at that point, ionic transfer stops. So after that, charge separation will not take place. Ion transfer will not take place. Charging of these two electrodes will not take place after that. It ceases, it stops. Because the chemical force is opposed by the electric force. Now both becomes equal. So that is the maximum potential. The potential difference corresponding to that point is the maximum potential difference, or that is the maximum voltage that can be produced in the cell. Clear? Now, I am connecting an electric lamp using an aluminum wire. Aluminum is a conductor. So materials which are having free electrons are called conductors, that we discussed in the last class. So aluminum wire is having free electrons, it is a good conductor. So I am connecting a lamp, I am connecting an electric lamp using conductors between the positive electrode and the negative electrode. Now can you tell me what happened? What happens? Here there are free electrons. The conductor will have free electrons. This copper plate is positively charged. This positively charged copper plate will attract these free electrons. So again, if you see this side, these electrons will repel these free electrons, and it pushes that towards the copper electrode. So copper electrode attracts the free electrons. So the free electrons within the conductor reaches the copper electrode. Now what will happen to the conducting wire? It will have only positive charges. These positive charges attract electrons from the zinc. Now zinc electrode is having more number of electrons, excess electrons. So those excess electrons are attracted by the positive charges of the aluminum wire. And those electrons which are coming to the conductor are also attracted by this copper electrode. Once again, this positive charges attracts electrons. So there will be continuous, as this progress, there will be continuous flow of electrons from the zinc plate to, so electron will flow from zinc plate towards copper plate. Zinc plate is negative, so lower potential, this is higher potential. Okay, so which one is doing that? So what has to be done in moving charges from lower to higher potential? So the chemical force produced here is the cause for that flow. So that chemical force, chemical pressure, it creates a pressure that pushes the electrons from zinc to copper plate through this electric lamp. Now, as the electrons flows from zinc plate to copper, what happens? The electrons recombine with the positive charges and neutralizing few. Here we are losing the extra electrons. We are keeping on losing extra electrons here. The electrons coming here recombine with the positive charges. So what will happen? The potential difference will go on decreasing. So when current flows, the potential difference starts to decrease. The charge at both ends decreases. So once the charge in the zinc plate decreases, because electrons are moving from this plate to other plate, so charge here is decreasing. When the charge decreases, electric force also decreases, the electric field decreases, and hence electric force decreases. When the electric force comes below that chemical force, ionic transfer starts. It once again moves hydrogen ions from here to here. That hydrogen ion will take 2 electrons from the copper, and hydrogen gas will be released. Okay, so potential difference is again maintained. This is the process. So potential difference is also maintained by the chemical force. So the chemical force produced here does 3 jobs. What are those? First, it is responsible for ion transfer within the electrolyte. Thereby it charges both the electrodes. Thereby, it created potential difference between these two electrodes. Second, when we connect an electric appliance in an external circuit, it causes flow of current. So, second job of this chemical energy is circulating current in the external circuit. And third job, it maintains the potential difference. When the potential difference starts to decrease, the charge is decreasing, so electric force decreasing, so chemical energy initiate ion transfer again. So that potential difference is maintained constant at its rated value. You got it? So let's move on to EMF. What is EMF? Electromotive force. Even though we call EMF as electromotive force, don't misunderstood as it is a force. It is not a force. EMF is an energy. This is an energy. So how will you define EMF? EMF is the energy spent in transferring 1 coulomb of charge in the battery circuit. So where this energy comes from? This energy is nothing but energy released due to chemical reaction in the battery, chemical reaction in the cell. This energy is nothing but chemical energy, and the corresponding force is chemical force. So EMF is produced in a battery. So that EMF is the chemical energy spent in transferring 1 coulomb of charge in the battery circuit. So in the external circuit, 1 coulomb of electron is transferred from zinc plate to copper plate. Within the electrolyte medium, 1 coulomb of ions are transferred. So in the external circuit, transfer of electrons take place, and within the electrolyte medium, transfer of ions take place. So that is the battery circuit. So energy required or work done in moving 1 coulomb of in transferring 1 coulomb of charge within the battery circuit is called as electromotive force. It is not an force, it is an energy. So EMF is work done, or energy use means equal to work done. So work done in moving 1 coulomb of charge within the battery circuit. So work done by charge. So joules per coulomb. Joules per coulomb is also called joules. So unit for EMF is also joules. That's all for today's class. And in the next class, we will study about resistance and the variation of resistance with respect to temperature. Thank you.